Researchers at the MIT Media Lab can photograph the fastest thing in the universe, light. They've developed a camera capable of capturing images at 1 trillion frames per second. What that means is that the images like this one can show light waves.
We are able to visualize light moving at 1 trillion frames per second. In order to do that, we capture movies of many identically looking pulses that propagate through the scene. And we computationally combine these movies to make one movie of the actual pulse.
It starts with a laser that fires a pulse 75 times a second. The camera, meanwhile, captures one line of the photo or video at a time. For this reason, whatever's being photographed needs to be still, and the light source, in this case the laser, needs to be replicated thousands of times. Once all of the lines of the scene are captured, about 500, the team stitches together the photographs, much like you would piece together a panoramic picture made of multiple images. To give you an idea of how fast 1 trillion frames per second is, consider this. This report you're watching is playing at about 30 frames a second. Super slow motion is in the thousands of frames per second range. At 1 trillion frames per second, it would take a bullet shot from a gun 3 years to travel from one side of the screen to the other. With such speed, there are more uses for this technology than just snapping pictures.
We are able to use this to improve on photography, to relight pictures. With the knowledge of the scene, with the additional knowledge of the scene we have, we could, for example, change the lighting of the scene, we can replace materials in the scene, we can learn something about the objects in the scene. We can learn more about the materials of the objects. We can also try to use subsurface scattering to learn about what's inside these objects by trying to figure out the time light took to propagate through a subsurface scattering material. We could try to do some kind of an X-ray with light.
It's possible that medical imaging equipment that takes up entire rooms today could one day be shrunk down to fit in your cell phone. And there's even more practical uses.
If we have the ability to process echoes of light in a consumer device, in the future you might look inside an object. For example, you could see if a fruit is very ripe, or you can look under your skin to see how the wound is healing, or you can walk into a room and take a picture and figure out which material is what, which one is wood, which one is fabric, and so on. And you can do all of that by analyzing these echoes of light.
There are even military and law enforcement applications that could use the technology to see around corners by analyzing light waves. The Camera Culture Group said that some even more exciting research will be announced in the coming months, so stay tuned for that. At the MIT Media Lab in Cambridge, Nick Barber, IDG News Service.